Tornadoes. These swirling vortices of wind are a testament to the raw power of nature. They are a phenomenon that has captivated and terrified humanity for centuries. Their destructive potential is immense, capable of leveling buildings, uprooting trees, and forever altering landscapes. But what are these forces of nature, and how do they form? Tornadoes are born from powerful thunderstorms, fueled by a complex interplay of atmospheric conditions. Understanding the science behind their formation is not just an academic pursuit, it's crucial for predicting their occurrence and mitigating their devastating impacts. By unraveling the secrets of these violent storms, we can better prepare for their fury and protect ourselves from their wrath. Imagine a column of air, spinning faster than the most powerful hurricane, reaching down from the sky to touch the earth. That is a tornado, a force of nature that demands our respect and understanding. Let's delve into the heart of these storms and explore the forces that drive their creation. Tornadoes don't just emerge from any thunderstorm, they require a specific breeding ground, the supercell. These colossal storms are characterized by their rotating updraft, a powerful current of rising air that forms the heart of the tornado-generating machine. Supercells are like towering skyscrapers of wind and rain, often stretching over 10 miles high. Within their churning depths, a perfect storm of conditions must align for a tornado to form. Warm, moist air from the south collides with cooler, drier air from the west, creating an unstable atmosphere ripe for powerful updrafts. As this warm, moist air rises, it cools and condenses, releasing tremendous amounts of heat energy. This energy fuels the updraft, causing it to rotate and strengthen, creating a spinning column of air within the storm cloud. This spinning column is the embryonic stage of a tornado, waiting for the right conditions to descend and unleash its fury upon the earth. The updraft is the beating heart of a tornado, the engine that drives its ferocious winds. Imagine a giant vacuum cleaner pulling air upwards at incredible speeds. That's the power of an updraft, capable of lifting cars, trees, and even houses into the air. As the updraft stretches upwards, it creates an area of low pressure at the base of the storm. This low pressure acts like a magnet, drawing in more air from the surrounding environment. This influx of air further fuels the updraft, creating a self-sustaining cycle of rising air and intensifying rotation. The updraft is not just a single column of air, it's a complex, dynamic system of swirling winds. These winds can rotate at speeds of over 100 miles per hour, creating a vortex of incredible power. When this vortex descends from the storm cloud and touches the ground, a tornado is born. While the updraft provides the raw power, it's wind shear that gives a tornado its deadly spin. Wind shear refers to the change in wind speed and direction with height. Imagine the wind blowing from the east at ground level, then shifting to blow from the south at a higher altitude. This difference in wind speed and direction creates a horizontal spinning effect in the atmosphere. This spinning effect, like a top set in motion, interacts with the updraft, tilting it from a vertical to a horizontal orientation. As the updraft tilts, it stretches and tightens the spinning column of air, intensifying its rotation. This process is akin to a figure skater pulling their arms in during a spin, causing them to rotate faster. Wind shear is a crucial ingredient in tornado formation, providing the final twist that transforms a powerful updraft into a destructive funnel cloud. Without wind shear, a supercell may produce heavy rain and hail, but it's unlikely to spawn a tornado. The enhanced Fujita scale measuring nature's fury. Tornadoes are not all created equal, they vary greatly in size, strength, and destructive potential. To better understand and categorize these differences, meteorologists use the enhanced Fujita scale, or F scale for short. The EF scale rates tornadoes from EF0 to EF5 based on the damage they cause. It's important to note that the EF scale doesn't directly measure wind speed, rather it uses damage to estimate the wind speeds that would have been necessary to inflict such destruction. By assessing the damage to buildings, trees, and other structures, scientists can assign a tornado an EF rating. This rating provides a valuable tool for understanding the intensity of a tornado and communicating its potential impact. EF0 and EF1, the first whispers of destruction. At the lower end of the EF scale are EF0 and EF1 tornadoes, often referred to as weak tornadoes. While these tornadoes may not possess the awe-inspiring power of their stronger counterparts, they are still capable of causing significant damage and should not be taken lightly. EF0 tornadoes, with wind speeds of up to 85 miles per hour, can damage trees, rip shingles off roofs, and displace mobile homes. EF1 tornadoes, packing winds of 86 to 110 miles per hour, can uproot trees, overturn mobile homes, and cause significant damage to roofs and exterior walls. While EF0 and EF1 tornadoes may not level entire neighborhoods, they serve as a reminder that even the weakest tornadoes can pose a threat to life and property. It's crucial to heed tornado warnings, even for lower-rated storms, and seek shelter immediately. EF2 and EF3, the growing roar. As we move up the EF scale, we encounter EF2 and EF3 tornadoes, classified as strong tornadoes. These storms possess significantly more power than their weaker counterparts and can inflict considerable damage. EF2 tornadoes, with wind speeds of 111 to 135 miles per hour, can tear roofs off well-constructed homes, demolish mobile homes, and overturn trains. EF3 tornadoes, packing winds of 136 to 165 miles per hour, can uproot trees, lift cars off the ground, and cause structural damage to even well-built buildings. The destructive force of EF2 and EF3 tornadoes underscores the importance of seeking sturdy shelter during a tornado warning. Basements, storm cellars, and interior rooms on the lowest floor of a building offer the best protection from these powerful storms. Section 8, F4 and F5, the apex of nature's wrath. At the top of the F scale reside F4 and F5 tornadoes, the most powerful and destructive forces nature can unleash. These monstrous storms are relatively rare, but their potential for devastation is unmatched. EF4 tornadoes, with wind speeds of 166 to 200 miles per hour, can level well-constructed homes, hurl heavy objects through the air like projectiles, and debark trees. EF5 tornadoes, the most intense of all, boast wind speeds exceeding 200 miles per hour. These storms can reduce even the sturdiest structures to rubble, leaving behind a path of unimaginable destruction. Thankfully, EF4 and EF5 tornadoes are relatively uncommon. However, when they do occur, their impact can be catastrophic. It's essential to have a plan in place for seeking shelter during a tornado warning, and to stay informed about weather conditions, especially during severe weather outbreaks. Section 9. Respecting the power, the importance of tornado safety. Tornadoes, regardless of their size or strength, demand our respect. These forces of nature can change course in an instant, making it essential to take tornado warnings seriously and seek shelter immediately. When a tornado warning is issued for your area, every second counts. Seek shelter in a basement, storm cellar, or an interior room on the lowest floor of a sturdy building. Stay away from windows, doors, and exterior walls. If you're caught outdoors, seek shelter in a ditch or low-lying area and cover your head. Remember, the most important thing is to protect yourself from flying debris, which can be deadly even in weaker tornadoes. Section 10. Understanding tornadoes, a key to preparedness. Understanding how tornadoes form and the dangers they pose is crucial for mitigating their impact. By staying informed about tornado safety, heeding weather warnings, and having a plan in place, we can better protect ourselves and our loved ones from these devastating storms. Knowledge is power, especially when it comes to severe weather. By learning about the science behind tornadoes, the EF scale, and tornado safety tips, we can become more resilient in the face of nature's fury. Remember, tornadoes are a part of the natural world, and while we cannot control them, we can control how we prepare for them. By taking steps to stay safe, we can weather the storm and emerge stronger on the other side. Section 11. Conclusion. In awe of nature's power. Tornadoes stand as a testament to the awe-inspiring power of nature. From their humble beginnings as swirling updrafts to their potential to unleash winds exceeding 200 miles per hour, these storms command our respect and attention. While we marvel at their might, we must also remember the importance of preparedness. By understanding the science behind tornado formation, heeding weather warnings, and having a safety plan in place, we can mitigate the risks posed by these powerful storms. Tornadoes are a part of our planet's story, a reminder of the incredible forces that shape our world. Let us approach these storms with a healthy respect for their power and a commitment to staying safe when they threaten.